ever heard of H. Tracy Hall? By David Dibble, Michelle Hatch, J.D. Lyon, MiKell MacKay, and Brittany Nelson. The diamond, a unique gift of nature to man. No other substance has its lasting beauty or durability. Since the beginning of recorded history, man has treasured the diamond. Ancient nobility from India, Persia, and Egypt sported large uncut diamonds. Ancient Egyptians drew lines in rocks with amazing precision. Scientists now say that only the diamond could have done this work. Alchemists from earliest Christian times until 1700 used magic and religious powers in attempting to change common substances into more valuable ones, including the diamond. Their efforts led to the beginnings of modern chemistry. Man's scientific attempts to make diamonds span the last 2 centuries. After Antoine Lavoisier concluded that the diamond was made of carbon, in 1792 the diamond rush began. Some of the world's most prestigious scientists joined in the race, including Nobel Prize winner Henry Moissan and Charles Parson, inventor of the turbine steam engine. In 1946, Dr. Percy Bridgman, with enormous financial backing, received a Nobel Prize for his powerful press that put graphite under great pressure, but he failed to produce the diamond. Meanwhile, at the University of Utah, young Tracy Hall became interested in the diamond. He began some of his own experiments. After earning a doctorate in 1948, he went to work for General Electric in Schenectady, New York. In 1951, General Electric initiated a program to try to make the synthetic diamond. Dr. Hall took the challenge. He felt that the key to the problem was in creating a device that could attain ultra-high temperatures simultaneously with ultra-high pressure. In spite of painful resistance, meager funding, and criticism from superiors, he created such a device, the revolutionary belt, which far exceeded anyone's highest hopes. All other presses were now obsolete. Dr. Hall became discouraged after hundreds of runs on his new equipment failed. General Electric was considering abandoning the project. Then, one cold wintry morning on December 16, 1954, Tracy made another run, this time using a different catalyst, triolite. In an interview with us on November 29, 1991, Dr. Hall tells about his experience.
I broke open the sample cell after removing it from the belt. It cleaved near the tantalum disc. Instantly my hands began to tremble. My heart beat wildly. My knees weakened and no longer gave support. Indescribable emotion overcame me, and I had to find a place to sit down. My eyes had caught the sparkling light from dozens of tiny crystals growing out of the tantalum. It took about 20 minutes to regain my composure, and I knew that diamond had at long last been made by man.
Immediately at General Electric there was a scramble for a piece of the glory, and on February 15, 1955, there was an impressive press release. Most United States newspapers carried as front-page news the story that the diamond had been made at General Electric in Schenectady, New York. The credit for the invention was given to General Electric, and Dr. Hall's name was not even mentioned in many newspapers. General Electric succeeded in having the government declare that the process for making diamonds was classified as secret. Scientific journals could only talk in generalities, thus further robbing Dr. Hall of the impact of his discovery. There are no biographies written on Dr. Hall. His name is not mentioned in encyclopedia accounts or in many publications about the discovery of the synthetic diamond. He is not a fellow in the American Academy of Scientists, an honor given to many with contributions of less impact. Nevertheless, United States patents for the belt and diamond synthesis bear his name only. And finally, 17 years after his achievement, the American Chemical Association recognized Dr. Hall and gave him their highest annual award, the 1972 Gold Medal for synthesizing the diamond. Compensation by General Electric for his extraordinary achievement was a demeaning $25. When Dr. Hall learned that new PhD employees with no experience were getting paid more than he was, he left General Electric and became Director of Research at Brigham Young University, during which time he invented other high-pressure equipment and new superior types of diamonds. As a result, there was ignited a large, frenzied effort in high-pressure, high-temperature research. It was from Brigham Young University that the world learned about the details of making diamonds. At first, General Electric did not recognize the potential of the synthetic diamond. The Norton Company was commissioned to test the synthetic diamond in a grinding wheel. To their amazement, it worked over 100 times better than the natural diamond grit. Immediately, an industrial synthetic diamond tool business was born that would become over a billion-dollar business. In today's world, no society can survive as an industrial nation without the synthetic diamond. Here are the reasons. Fact: the synthetic diamond has properties far superior to any other substance on Earth, including natural diamond. Nothing else can compare with its combination of hardness and durability. It is required in industry for wearability and precision in grinding, polishing, drilling, and cutting hard materials. In many cases, nothing else can begin to do the job. Fact: the synthetic diamond is the best thermal conductor known to man, better than natural diamond. It transfers heat away from itself. These unique properties are required in modern electronics. Fact: the synthetic diamond is an economic necessity to industry in our nation. The price of natural diamond grit was $5 per carat in 1955, and the synthetic diamond was 35 cents per carat in 1990. Without the synthetic diamond, manufacturing costs would soar. Manufacturing would not be competitive in today's market without this remarkable discovery. Fact: there's not nearly enough natural diamond to supply the industrial world. The United States has no natural diamond mines of its own. Without the synthetic diamond, we would have to depend on imports for this essential commodity. The supply of synthetic diamond is limitless. Fact: the tiny crystals of the synthetic diamond can be cemented together in a diamond matrix. Thus, a solid diamond can be made into any shape required for diamond tools. Fact: the birth of the space industry in the 50s and energy crisis in the 70s created a need for new, lighter, stronger metals for space equipment and cars. A composite aluminum silicon metal fit the bill, but these materials were so hard that they could not be tooled by natural diamond. Synthetic diamond was the answer. Modern rockets, missiles, bombers, airplanes, ships, and submarines are made of these materials. National security is thusly dependent on the synthetic diamond. Again, we see the significance of this discovery. Fact: without synthetic diamond, productivity and quality in industry would decline severely. The following industries have been revolutionized by the synthetic diamond and would suffer serious repercussions if it were removed. Computers. The diamond is used for drilling circuit boards, polishing hard drives, and as thermal conductors. Oil well drilling. Drills are over 100 times more effective with synthetic bearings and bits. Automobiles. Gears, bodies, windows, and many other parts must be tooled by the diamond. The billion-dollar cement industry. Roads are surfaced and cut for safety and extension grooves. Huge cement structures are cut like peanut butter by the diamond. Optical lenses and optics for medical endoscopes, medical and dental equipment. Glass and crystal are cut and polished by diamond. Wire making, quarrying stone, and mining are heavily dependent on the cutting capabilities of the synthetic diamond. Nuclear plants require the synthetic diamond for their construction. There are countless other major multi-million-dollar industries heavily dependent on the synthetic diamond. Some probable future uses of the synthetic diamond will be drilling very deep holes to tap the thermal energy of the Earth, underground tunneling for vacuum subway systems, making travel faster, cheaper, and cleaner, revolutionizing microelectronics with new laser-proof diamonds. Where would we be if these industries cannot utilize the synthetic diamond? They certainly could not compete in today's market. Automation as we know it would cease to exist without the synthetic diamond. The exchange of scientific ideas passed down from one century to another led Dr. Hall to his discovery of the process for making diamonds. In spite of his encounter with opposition, criticism, meager funding, and lack of credit, he created a product that changed technology in our world forever. The synthetic diamond is so important that an industrialized nation cannot survive as such without it. Only bits and pieces of published information can be found on the impact of Dr. Tracy Hall's extraordinary contribution. Sadly, this presentation is the only synthesis which has been presented on the impact of Dr. Tracy Hall on our world. Who is Dr. H. Tracy Hall? Surely he deserves a significant place in American history.